Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Danish Alman bin Ramlan and I am from Group 4. I will explain about the closed loop circuit and demonstration the Simulink block diagram. Okay, at the first we must construct the closed loop circuit with we have a step block diagram, sum block diagram, PID controller block diagram, transfer function block diagram, and last one scope is for analyze the output. So we must construct three of them. The first one we have with a different PID controller. Okay, the first one we have the P controller. Second one we have PI controller, and the last one we have PID controller. Okay, let's go. We analyze the P controller first. We have the transfer function 16 over s power of 2 plus 2s plus 4, and we must enter the proportional, which is p value, from the from our manual calculation. For our group we have 0.5, and after that we apply, we okay, and we run it, and we open the scope. So this is the graph for the pin controller. Okay, after that we open the PID controller block diagram and we tune it. Okay, this is a graph from PID tuner. So we have the dot graph, which is our block response, and the board graph, which is tune response. So we click the show parameter, and we make the comparison between our block graph and tune graph. So our block graph use P equal to 0.5, and our rise time for block and tune, block 0.378 second and tune 0.422 second, and setting time block 3.93 second and tune 3.51 second. So after that we update the block, and we have the smooth one graph, and we can see the block and tune parameter is same, and we can analyze from this parameter. Okay, we close, and the most important thing, we must make sure the PID tuner graph, which is steady state at 0.6 amplitude, and we compare it with our scope. Okay, it gives the same result, steady state at 0.6. Okay, for the PI controller, you open it. So we enter the value from manual calculation, 0.45 for proportional, and integral 1.2, and we okay, we run it, we open the scope, and we get the sine wave graph. And after that we open the PI controller, we turn it, this is our PID tuner for PI controller, and we click show parameter to be analyzed. Okay, we have the detail for our block response and to response. and we update the block. Okay, after we click the update the block, we use the block. We use the same value for block and to respond. So we can see P is same value, I is same value. Alright, we can see the graph reach the steady state at one amplitude, and we compare to the our scope. We run it. Okay, it will give the same result, which is the blue one color graph reach the steady state at one amplitude. And the last one, we analyze the PID controller. We click it. So we enter the value that come from manual calculation. Our proportional 0.6, our integral 0.72, and our derivative 0.18. Okay, we run it. We open the scope. Okay, this is our output for the scope PID controller, and we compare to the PID tuner. Run. Okay. Okay, we tune it. We can see the block response and to response, and we click the show parameter. Our PID value for block 0.6, 0.72, and 0.18, and our tune give the tune value, and we can see the setting time for the block and tune. Rest time also, which is block response use 0.486 second and rest time 0.58 second. You can see the overshoot block 0% and tune 1.48%. So we update the block. We can see the all of parameter in this use the tune version. We get the smooth and nice one graph, which is it reach steady state at one amplitude, and we compare to the our scope. We run it. Okay, it will give the same answer, same output, steady state at one amplitude. Okay, that's all for me. Thank you.
Hello, Assalamualaikum. My name is Daniel Anwar. In this project, I will explain about open loop circuit. The open loop circuit is a form of control system where the output is dependent on the input, but the controller or input is independent of the output. Since the system doesn't have a feedback loop, they are also referred as non-feedback system. So this is a step block diagram, sum block diagram, PID control block diagram, transfer function block diagram, and scope block diagram. This we can get in Simulink. So first we need to run the simulation. First, we need to run the simulation. This is the default graph. So we need to check the PID tuner. We need to scroll down, click tune. This is error because they don't have feedback. So we click OK. We need to see the parameter by clicking the show parameter. So here we know that this is the parameter. So we need to update the block. So the block is the same as the tune. So now we need to close and run back the simulation. Now we can see it goes decrease. You can check the tune. Error because there's no feedback. So we need to show the parameter, update the block. So the block will be same as tune. So click the X, then run back the simulation. And lastly, we need to insert the value of PID in the PID controller. So the P is 0.6, I is 0.72, and the lastly is 0.18. This value is the same as the closed loop circuit. So this value this value is same as closed loop circuit. So click apply here, click OK, and run the simulation. To see the result, now we can click the scope, and now we can see the graph is increased. Now we can check the PID controller. We select tune. This is error because there is no feedback. Next, this is gain. Next, we will proceed to open loop circuit, but with gain. So this basically is same as open loop circuit, but the PID controller it will replace with gain. So now I will run the simulation. We can see the output here. Let's go. So this is the graph for gain output. So that's all from me. Thanks.